Okay, let's take a look at these couple here. The first one, we're subtracting, so we're going to write them out. 5x squared minus 9x plus 5. And we're going to line them up. 8x squared goes under the 5x squared, plus 7x goes under the negative 9x. And our negative 11 will go under the 5. And we are subtracting here down each column. So 5 minus a negative 11. Positive 16. 5 minus a negative 11 becomes 5 plus a positive 11. So careful with the negatives. Next one is negative 9x minus 7x. Negative 9 minus 7 is negative 16x. And 5x squared minus 8x squared, 5 minus 8, negative 3x squared. So it's the negatives you got to be careful of there. The next one, we're multiplying, there's nothing we can do inside the parentheses. So we're going to multiply through by the 7, x to the 5th, y to the 8th. So 7x to the 5th, y to the 8th, times 11, x to the 4th, y squared. 7 times 11, 77. X to the 9, 5 plus 4 is 9, and y to the 10. Perfect. Then 7x to the 5th, y to the 8th, times a negative 4, x to the 3rd, y to the 5th. 7 times negative 4, negative 28. X to the 8, good. 5 and 3 make 8. Y to the 13, good. Y to the 8th, y to the 5th makes 13. 7x to the 5th, y to the 8th, times 6x, y to the 6th. 7 times 6, positive 42. X to the 6, good. 5 plus, we think of that as a 1, so 5 plus 1 is 6. Y to the 14th, good. 8 plus 6 is 14. And that is it. That's all we can do there. Any questions so far?
I always mess that up because I want to do the y to the 8 to the left. Like I break it up. I don't know why.
Oh, sure. You're trying to split them down by y's and x's. And well, sure. Okay. If you want to go back and redo that, go ahead. Okay, now for the division here, remember we can take each piece separately. 21 x to the 8th y squared divided by 7 x to the 3rd y squared. So 21 divided by 7 is 3. X to the 5th, good. 8 minus 3 is 5. Y cancels out. Y squared divided by y squared cancels out. Now we have the 35 x to the 5th y to the 3rd divided by 7x to the 3rd y squared. 35 divided by 7. 5. Positive 5, so plus 5. X to the 2. 5 minus 3 is 2. And y, yeah, just y. Y to the 1. 3 minus 2 is 1. So y to the 1 or just y. And then we have negative 14 x to the 3rd y to the 4th divided by 7x to the 3rd y squared. Negative 14 divided by 7. Negative 2. X divides out. X to the 3rd divided by x to the 3rd cancels out. Y squared. Perfect. Any questions on that one? Okay, wonderful. So what we're going to look at today is we're going to look at reversing those processes. Kind of like with our numbers. If I asked you to factor, well, let's just say we asked you to factor 30. If you recall, we did factor trees. What's one number that divides into 30? 10. Good. 30 divided by 10 would leave us with a 3. Now the 3 is prime, so I'm going to stop there. But can I split up the 10 further? I sure can. 10 can split into 2 times 5. Those are both prime. Those cannot be split up. So my factoring of 30 is 2 times 3 times 5, putting them in order from smallest to largest. Those are the smallest pieces I could multiply together to get 30. We looked at problems like the second one we did here today that were like this. 5x squared times 3x minus 7. As we multiply that out, 5x squared times 3x makes 15x to the third. 5x squared times negative 7 makes negative 35x squared. If we were asked to factor this, what it's asking us to do is break it down into things that divide into it. Well, we just multiplied it together, so we know it divides by 5x squared, don't we? How could we tell it if we hadn't just did this multiplication? How could we tell that divides by 5x squared? Well, yeah, they're both divisible by 5 is one of them, and they have x's in both of them. It's called the greatest common factor. Now, on our last test, we looked at the least common multiple, right? The least common multiple was bigger than both numbers. It was the smallest number that both of them can go into. Greatest common factor is the largest number that can go into both of them. And if you recall, greatest common factor between two numbers, and here we are looking at the 15x to the third and 35x squared. We ignore the negative because that doesn't affect us here. The negative doesn't matter. When we did least common multiple on this last test, you did the numbers and then it was the highest power of the variable. When we did greatest common factor a couple of weeks ago, or a few weeks ago now, you did the numbers. What is the largest number that goes into both 15 and 35? That is the 5, right? For the variables, it was the smallest power of the variable. So here that would be the x squared. So 5x squared is the greatest common factor for 15x to the third and 35x squared. So now when we did this up here, when we found that 10 was a factor, how did we get the 3? You did 30 divided by 10, right? Give you the 3. That's what's left over after you divided out the 10. So down here, how do we find out what the other factor is? If 5x squared is our first factor, the other factor is going to be found by dividing that by 5x squared. 15x to the third divided by 5x squared is 15 divided by 5 is 3. X to the third divided by x is x. Negative 35x squared divided by 5x squared. Negative 35 divided by 5 is negative 7. X squared divided by x squared cancels out. So there it is. We just factored that. So let's take a look at another example. Let's say we have 24 x to the fifth minus 16x to the third. So looking for a greatest common factor, we're looking at the numbers. What is the largest number that will divide into both 24 and 16? 4 will divide into them, 2 will divide into them, 4 will divide into them, 8 will divide into them. Is there anything bigger than 8? 8 is it. 8 is the biggest number. So 8 is the greatest common factor for the 24 and 16. Now how about for the x? X to the third. We go for the smallest variable. It's x to the third. Smallest power of the variable. X to the third. How do we figure out what's left over? Well, we divide this by 8x to the third. So we start out with 24x to the fifth divided by 8x to the third, which is 3x to the second. 24 divided by 8 is 3. X to the fifth divided by x to the third. 5 minus 2 is 2, so x to the second. Now it's negative 16x to the third divided by 8x to the third. Negative 16 divided by 8 is negative 2. X to the third divided by x to the third cancels out. It's gone. So there we go. We just factored it out. If we were unsure of ourselves and we wanted to double check, you could go back and multiply it out and make sure we get back to that. And we would, but I'm not going to here. So for this one, looking at the numbers 35 and 28, is there a greatest common factor? Is there a common factor? There is. So what's the greatest common factor? 7 is the largest number. It'll go into both 35 and 28. For the variables, we can go each variable at a time. For x, what's its smallest power? Just 1 or just x, right? So x, how about for the y? Just y. Y to the 1 or just y? So we've got 7xy is our greatest common factor. So now we're going to divide by 7xy. 35 x to the third y divided by 7xy. 5 x squared. 35 divided by 7 is 5. X to the third divided by x, we think of it as x to the 1. 3 minus 1 is 2, so it's x squared. And y divided by y cancels out. Now it's 28xy squared divided by 7xy. 28 divided by 7 is 4. Now it's a positive 4, so let's put in a plus 4 there. X divided by x cancels out. Y squared divided by y. Just y. So 7xy times 5x squared plus 4y. This, the factors of that. Questions?
So do you have to put the like 7xy times that has to be before standard answer for all of our answers? Like,
Yeah, you have to have both pieces. You have to have this piece and then what's in the parentheses.
okay.
Yeah. So looking at this one, figure out for me, I have 3 terms here. So I have to look at 16, 32, and 28. I'm going to ignore the negative. What is my greatest common factor? 4, it looks like. So for the numbers 16, 32, and 28, 4 is the largest number that goes into all of them. For my variables, how about for the x? No. Why isn't there? There's no x in this one here, is there? So that the variable to be part of the common factor, it has to appear in every one of them. So since there's no x in this one, there is no x in the common factor. How about y? Just y is the smallest power of y. Y to the 1 or just y? So 4y is my only common factor, my greatest common factor. So I'm going to divide by 4y to get my other factor. 16 divided by 4, 4. What do we do with the x to the 5th? Stays x to the 5th. Nothing happens to it. What happens to the y? Divide it out. Y divided by y is divided out, so it's gone. 32 x squared y squared divided by 4y. 32 divided by 4? 8. It's a positive 8, so plus 8. X squared, nothing happens to it. There's nothing to divide it by. How about y? Just y. Y squared divided by y is just y. Negative 28y to the 3rd. Negative 28 divided by 4? Negative 7. And yes, y to the 3rd divided by y squared. 3 minus 1 is 2. So there is my factoring. Any questions so far? I'll have you guys try one. In your notes, try to do that one. Prime factor that. Find the greatest common factor and then divide it out to find the second factor. So what is my greatest common factor? 3. How about for my variables? X is the only variable. Y doesn't appear in the first one. Z does not appear in the last one. So only 3x. That's easy to do. That's one of the reasons why I put a little line through my z's. So now I divide by 3x. 9 divided by 3 is 3. X to the 5th divided by x. X to the 4th. That nothing to do with the z squared. Negative 18 divided by 3. Negative 6. X squared, and then nothing to do with the y or the z. 12 divided by 3. 4. X's divide out, and I do have the y to the 3rd that nothing happens to. And that's it. Any questions?
You still bring the lines down even?
Yep, even because there's nothing to divide them by, so they're still there. Nothing happens to them.
Okay, that's where, yeah.
Why doesn't the 2 change? Oh, duh.
Because there's no z to divide by. It's okay. 6x squared yz and 4y3. Okay. Let's try one more. Actually, do this as y squared. So 24x to the 3rd y squared plus 32 x squared y to the 4th minus 16 x y to the 6th. Try to factor that one in your notes. So for my greatest common factor, what am I going to get? 8 will work. There we go. So we got 8. How about for the variables? X, y squared. So we're going to divide by the 8xy squared. What do we get for the first term here? 3x squared. Perfect. 24 divided by 8 is 3. X to the 3rd divided by x is x squared. Y squared divided by y squared cancels out. What about our next one? Positive 4 xy squared. Good. 32 divided by 8 is positive 4. X squared divided by x is just x. Y to the 4th divided by y squared is y squared. Our next one, negative 2 y to the 4th. Good. Negative 16 divided by 8 is negative 2. X divided by x divides out. Y to the 6th divided by y squared is y to the 4th. How many of you got that?
If I divide my whole thing
Yeah. Well, now, there's a good thing, a good question. I'm glad you said that. Because what if you just used 4? You would end up getting something that looks like this, right? Well, as I look at this, you see that they're both still divisible by 2, right? Or all 3 of them are still divisible by 2. You could divide out another 2 if you wanted to. If you divided out another 2, you get right to where we are up here. What do we do with that 2? That 2 combines with the 4x y squared. 4 times 2 is 8. So if you get done, if you take a chance and you look at it, and you see that each of the numbers can still divide by something, or if you see that there's still a variable that's in each one of them, you know that there's something more you could have divided out. We also multiplied things like this. We didn't do a lot of them, but we've done some. We did some of them like this. Then we also used, what was the little acronym we used? FOIL. I'm going to use FOIL to do this, just because it's going to be easier to reverse it if we do FOIL. So F stood for first. The first 2 digits, x times x, makes x squared. O stands for outside. The outside 2 digits, x times 5, makes positive 5x. I stands for inside. 3 times x makes positive 3x. I always put that under the other x. And then L stands for last. 3 times 5 makes 15. Then I combine what I can combine here. Nothing combines with the 15. 5x and 3x make 8x, so positive 8x, and x squared. If I were asked to factor this, in other words, to reverse that process, split it back up into those pieces, what I see about what I did here to combine them is the x squared. That was just the F in FOIL. It comes from the first 2 digits. The 15, that was just the L in FOIL. That comes from the last 2 digits. So if I wanted to split this up, if I wanted to reverse this process, I have to find numbers for the first digits are going to multiply to make x squared. Well, that's pretty simple. Only things that multiply to make x squared are x times x. Then for my last 2 digits, I have to find numbers that multiply to make 15. I only have 2 possibilities here. 1 times 15 or 3 times 5. How do I know which one? Well, I don't until I try them. If I put in 3 and 5. Now I also know that they're both positive or both negative because it's a positive 15. So I can check to see if those give me the 8. So now I've used, in my FOIL, I've used the F for the first and L for the last. I still have the O and the I on there, the outside and the inside. The outside and the inside is where the 8 came from. It's the outside plus the inside. So let's check on the outside and inside and see if I get 8. On the outside, I have x times 5, which is 5x. On the inside, I have 3 times x, which is 3x, which adds to make 8x, which is what I want. So that is telling me this is the proper factoring. Now, of course, we started out by multiplying two algebraic numbers together to get the x squared plus 8x plus 15. What if we don't have the luxury of seeing it multiplied out? So let's do x squared plus 8x plus 12. Step 1 is always going to be, even though I didn't really do it on the last one, check for greatest common factor. Are there any common factors here? No, because this is just a 1 here, right? So there's no numbers, and there's no variable here, so there's no variables. So there is no common factor. So I can't take out a common factor. We should always check for that first. Step 2 depends on how many digits there are. If there are 2 digits, we're going to do special products. We'll get to those later on. If there are 3 digits, we're going to do what we've been looking at. That's that FOIL and reverse. Or reverse multiplication. There's 4 digits. We would do something called grouping, which we might not get to. We may stop before we get that far tonight. But so this one has no greatest common factor. So in our next list, which one are we going to use? How many? Yeah, 3 digits. So FOIL and reverse. So that's this thing. We know it's going to be 2 two-digit numbers multiplied together. What do I know about these first 2 digits? You have to multiply to make x squared, so they're both x's. What do I know about these last 2 digits? They're positive, and they multiply to make 12. So they could be 1 times 12. They could be 2 times 6, or they could be 3 times 4. Let's try 3 and 4. So plus 3 plus 4. Let's double check it. We're going to check the outside. X times 4 is 4x. Let's check the inside. 3 times x is 3x. That multiplies to make, well, adds up to make 7x, I should say. 4 plus 3 is 7x. It's not what we want, is it? We want 8x. So 3 and 4 don't work. So we've got to do 1 and 12 or 2 and 6. What do you want to try? 2 and 6. Good. We double check that. On the outside, x times 6, 6x. On the inside, 2 times x, 2x, which adds up to make 8x, which is what we want. So this is our factor. X plus 2 times x plus 6. Any questions? Now, some of you might be seeing that there are some shortcuts. You look at it and say, okay, they got to multiply to make 12. And I say, well, they got to add to make the 8x. And it's good that you're seeing that. It's one of the reasons why we do this. It's called combinatorial thinking. You're thinking about combinations of numbers combined in different ways. Now, it does get more difficult as we go on. But for right now, I'm going to have you guys try one of your notes. Let's do x squared plus 4x plus 3. That was actually relatively simple, but we'll... So there is no greatest common factor. There is no common factor. So we're going to do this FOIL in reverse. X and x here. What are our other two? Plus 1 and plus 3, right? Really, there's no other option when that last digit's 3, is there? Let me give you one that might be a little trickier. That was it. Yeah, x plus 1 and x plus 3. When these two have to multiply to make 3, right? So the only option is really 1 times 3. I can double check it. X times 3 is 3x. 1 times x is 1x. That does add up to 4x. We will. You look like you have questions over there. No?
We'll explain.
Okay.
Way more work.
Sure. Let's take a look at x squared plus 25x plus 24. That one might be a little more difficult. So here there's no common factors. So this is going to be x times x to make x squared. The other two numbers have to make 24. So we have 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Those are our possibilities. Which one do you want to try? 1 and 24. Okay. 1 and 24 is the one that works. X times 24 is 24x. 1 times x is 1x. That does add up to 25x. I picked that because that's usually the last one people try is 1 and 24. Usually they try 4 and 6, 3 and 8 first. Any questions? What's that? This one here is not a lot more difficult. It looks weird because what's different about it? There's a negative. It's a negative 7x there. Process is still the same. First of all, are there any common factors? No. It's still 3 digits or 3 terms, so we're going to do FOIL in reverse. X squared is still split into x times x. 12, either 1 times 12, 2 times 6, or 3 times 4. Now that's a positive 12, which means it can be created by multiplying 2 positive numbers or by multiplying 2 negative numbers. If they're both positive, there's no way we could get a negative 7 out of it. So what that's telling us is that both of these numbers, whatever they are, must be negative. So which ones do you want to try? 1 times 12, 2 times 6, 3 times 4? 3 and 4? Okay, somebody's starting to see a pattern, right? We just add them together to get the middle one. So let's check it, just to be sure. X times negative 4 is negative 4x. Negative 3 times x is a negative 3x. And yes, negative 4x plus negative 3x is negative 7x.
This is called factoring.
Called factoring, yes. What's different here? There's a negative again, but now it's on the last digit. Once again, common factors? No. So we're doing our FOIL in reverse because it's 3 digits. Well, x squared is still x times x. But now since that's a negative 10, it's either got to be, well, it has to be 1 positive and 1 negative number multiplied together. So negative 10 can either be negative 1 times 10 or 1 times negative 10. Negative 2 times 5 or 2 times negative 5. Okay. I'm going to do this. I'm going to try positive 2 times negative 5. On the outside, x times negative 5 is negative 5x. On the inside, 2 times x is a positive 2x. Negative 5x, positive 2x make negative 3x. Is that what we wanted? Not quite. We wanted a positive 3x. But the reason I did that is to show you what we got is the right number is 3 is just the opposite sign. It's negative instead of positive. Which means that just has to be a negative 2 and this a positive 5. Now when I check x times 5, it's 5x. Negative 2 times x is negative 2x, which adds up to make 3x, which is what we want. Questions? So what happens if it is negative, or if it's 2x squared plus, well, what can I put in here? 11x plus 12. Are any common factors? No. The 11 doesn't divide by anything, so it can't be any numbers. So we're going to try to do FOIL in reverse. Well, this is now 2. These two have to multiply to make 2x squared. The only way that can happen is if this is 2x and x. 2x times x makes 2x squared. These two numbers still have to multiply to make 12. So it's either 1 times 12, 2 times 6, or 3 times 4. Which ones do you want to try? Be brave. 1 times 12, let's try it. Plus 1 plus 12. 2x times 12 is 24x. 1 times x is 1x. That adds to make 25x. Not what we want. But here's the issue. Because this is 2x and x, we have to try them in the other order. If I put 12 here and 1 here, let's see if that changes anything. Two x times 1 is 2x. Or 12 times x is 12x. That adds up to 14x. It does change stuff, and it's closer to what we want, but it's not what we want it to be. So the 12 and the 1 are not what we're looking for. What do you want to try next? If I want to do the 2 and 6, 2 and 6 are both even, so there's no way they could ever add up to a negative number, is there? So I know the 2 and 6 are to an odd number, I should say. There's no way the 2 and 6 can work, because they'll never add up to an odd number. So we're going to try the 3 and the 4. So 2x times 4 is 8x. 3 times x is 3x. That does add up to 11x. And yes, they do have to be in that order. If I had the 4 first and the 3 second, that wouldn't have worked. It would have been different. So 2x plus 3 and x plus 4. What do you think? Too much fun? Maybe not the terms you'd use. Well, how about this one? Common factors? No. So we're going to do FOIL in reverse. What do my first digits have to be? X and 2x or 2x and x, either way. My last two digits have to multiply to make negative 10. So it's either negative 1 times 10, 1 times negative 10, negative 2 times 5, or 2 times a negative 5. The middle number is a negative 1. Okay. Does that make sense? Okay. So now, which one do we want to try first? 5? Okay. Let's do negative 2 and positive 5. Let's try it out. 2x times 5 is 10x. Negative 2 times x is negative 2x. 10x minus 2x is 8x. That one's not what we want. But there's two things we have to be able to switch here. First thing I need to be able to switch is the numbers. Second thing is the signs. So I might make that a negative And this is a positive. And try that. It's a positive 2 and a negative 5. 2 times negative 5, or 2x times negative 5 is negative 10x. 2 times x is a positive 2x. Negative 10x, positive 2x is negative 8x. That's still not what we wanted. Notice it gave me the same result, it's just negative instead of positive. Does that mean we scrap the 5 and the 2? No. We got to switch their spots. Let's put the 5 over here and the 2 over here and try it. 2x times negative 2? Negative 4x. 5 times x? Positive 5x. That combines to make positive 1x. Is that what we want? Really close. It's positive and we want it to be negative. So that means I just got to switch that. Make that a negative 5. It'll make this a positive 2. And let's double check just to be sure. 2x times 2, 4x. Negative 5 times x, negative 5x. And that combines to make negative 1x, which is what we wanted. So there it is. What do you guys think? Too much fun? Just try them. It's pretty much exhaustion. You start to see the combinations in your head. You can start, rather than writing them out and testing them, you can start thinking, okay, 2x times something, x times something. What are the combinations? One's positive, one's negative. I'm making these up as I go, so obviously I'm knowing they come out. So, you start to see patterns in your head. You can figure them out. Now, to be totally honest with you, unless you're an engineer or an economist or maybe an actuary who's working with a lot of pure math or a math teacher, you're never on your job going to be asked to factor something like this. I used to do it a lot in engineering, finding, your point of maximum bend or point of maximum deflection and stuff like that in beams. But 98, 99% of careers don't involve factoring. But it's that forcing you to see patterns and forcing you to think in combinations. That, like I said, that combinatorial thinking of keeping two numbers in your head at once is what it's really good for. So I'm not going to sit up here and lie and say this is a very important skill for you to have if you're ever going to have a career. It's not. Let's go ahead and take our break. It's 4:21, so let's come back at 4:31.